Thank you. So, good afternoon, everybody. My name is Snir, and this is Unmasking Stealth Operation using UBA Superpowers. I said it in one sentence. So it's pretty long, but basically it's helping blue teams to identify very complicated and stealth attacks using machine learning and user behavior analytics, which is also pretty long. But okay, let's start. So a couple of words about myself. I'm from Tel Aviv. Long time security guy. I started as a software developer, became a penetration tester, red teamer, a lot of forensics, incident response research. I started my way in the Israeli Defense Force and also continued in the Ministry of Defense of Israel, which they're doing some very cool stuff. Today, I'm the head of cybersecurity of Varonis, which exposed me to the magnificent world of user behavior analytics, which we're going to speak about now. So, overview of, about what we are going to talk about this hour. UBA and machine learning, security point of view, and some insight about UBA from my experience, what we need to learn and what I recommend you to learn. We're going to cover some stealth operations. I'm going to show like a generic flow, and then we will talk about the data we have in the organization in order to answer and those kind of threats. And we're going to talk about some models for blue teams. There is a lot of mathematics in machine learning and UBA. I'm not going to talk about all the mathematics because I think we have only 1 hour and it's more cool to talk about cyber than mathematics. I'm not going to focus on endpoints. Rather, I'm going to focus on the whole organization, on key points within the organization. And you're going to ask yourself a couple of questions about the models and the things that I'm doing here. There is some false positive, false negative in this perspective of identifying threats. It's complicated and it all depends on what you're learning and which models you have, and I will help you to understand how to look on things from my point of view. So, like every cybersecurity talk, this is the highlights from 2017, just to show how much the world is insecure. We have many security solutions, a very good one actually, and all those kind of attacks, they like happening all the time each year. The impact is huge, and why is it still happening? Why with all the security solution and all the things that we have and all the mature security guys that trying to solve security issues and to catch those hackers, still those kind of breaches happening. So this is where UBA coming to place. UBA, it means user behavior analytics. It's based on machine learning and mathematics. It's analyzed not only the user. In the past, I think 2 years, we heard about UEBA. So the letter E referred to entity because inside the organization, inside your network, you don't only have users. You also have some entities, which are services, computer accounts, and different type of things that have also behavior and behave within the network. So we need to understand how they behave and to also implement some security aspects on them. Using the key point of UBA is learning. You need to understand what you want to learn and how you want to learn it, because past activity is the strongest tool that you have in order to compete with the attackers. If you can look back and see what's going on, you can build a better profile. Okay, we're going to talk about also building a dynamic profiles and searches for pattern that indicates abnormality. I don't want to look for attacks. I want to search for abnormal activity. Why? I want to see what I don't know. This is the abnormality. This is the power of UBA. Sheep and wolf. Okay, so most of the people that will see it, you say, okay, this is a mean wolf. If we want to save the sheep, we want to do something with the wolf, right? Because wolves eat sheep. But maybe it's not a bad wolf. Maybe the wolf is living with the sheep in peace. Maybe it's like the wolf from Games of Thrones. I don't know. Maybe it's okay. So I don't familiar with many nice wolves, but there are some nice wolves. And every time that I see a wolf next to a sheep, do I want to do something about it? If I will see it a lot, maybe it's not a risk. Maybe that wolf is okay. Maybe the sheep is the problem. Maybe the sheep don't need to be there. Why the sheep is next to the wolf? So this is, I think, the main perspective of UBA. Before you're taking some action, before we want to say, okay, this is an attack, this is a wrong scenario, we want to look back, we want to look on the entities and to check if it's actually wrong before we are sending it to someone else to check it, because there are a lot of wrong stuff within the organization. But before we are addressing them, we need to understand if it's actually wrong or not. So this is one of my key point of view that every day in my work I'm trying to raise every day, because it's very hard. Till now, from what I'm seeing, it's all about attackers and security solutions. We're trying to learn attacks, we're trying to learn patterns, we're trying to search for exploitation and for attack patterns and for attack vectors and see, okay, this is the group of attackers staying in Russia, this is the Asia attack group, this is the Israeli-based attack group, so we need to learn the patterns of attack and then to build some model in order to catch them. From my understanding of machine learning and user behavior analytics, it's a bit not so good to use big things like machine learning in order to learn patterns, in order to learn something like attacks. The thing is that attacks always changing. The attackers are very strong, very smart. They're trying to change their way, the course of attacks every time, which means that the attack data are always changing. And when we are talking about machine learning, just as an overview, we want to have a lot of data, huge amount of data. As much as data we have, it's better there is, okay? But instead of the amounts of data, we want to have a representative data. Attack data is, I think it's, and from what we are seeing, it's a very small portion of the data that we have. And in order to build the right models and in order to see the abnormality, we cannot base ourselves on data that are constantly changing all the time. And when we're trying to implement UBA and machine learning on those kind of patterns, we are actually using it in not so good way, because we are missing the point of machine learning. We are missing the points of let's learn the data and let's find the abnormality. But if you learn all the time abnormal data, the value will be limited. Exactly what I'm saying is, instead of learning the attacker, let's learn the organization. Okay, so the developer will be a developer all the time. He may change projects, okay? I'm now working on a Java project on this QA environment and with those people, and then I will change team and I will go to work with that team on a .NET solution, and maybe I will try to do some DevOps. But developer is a developer, IT guy is IT guy, financial guy is a financial guy. They have the same patterns. So I can take that data and to find a normal behavior of all the employees and all the organization that I have. I have also services. Services are usually very like they have the same time and the same hour that I'm running those services in the same computer, in the same environment. So if I can base my learning on the data that are acting the same, instead of basing my learning on things that are constantly changing, I can open my organization to new identification. Because if I'm learning something that I know that could happen, we need to face 0 days attack, new exploitation, new attack vectors. The attackers are moving along and progressing all the time. I don't want to learn them. It's too dynamic, it's too unpredictable. Let's learn the organization, because the organization is not going to attack me. Unless it's insider, but insider is like an attacker from my side. So let's learn the organization. Let's create the profile, the right profile, and if I will see abnormality here and abnormality there, then I will see that something is wrong. I can use machine learning to find the abnormality only with data that is representative. Okay? So this is my takeout for machine learning and UBA, and I will try to move with that concept forward through this presentation. So we said that we are looking on peacetime activity. We are learning the actual users, the actual organization, and not learning attacks. So learning attacks for me is it's kind of a blacklisting. And if we are working as a blacklist, we're losing the superpower of UBA. Because blacklisting may cause false negatives. We want to catch everything. And stealth operation is on the rise, and we need to catch them. Slow and low is on the rise. With slow and low, we will not see any jumps, any patterns. It's all trying to combine to normal activity. So you're not going to see some jumps there and that. So you need to find the small things, and in order to find the small thing, you need to work as a whitelist. Okay? Identify what is normal to uncover the rest. This is my perspective to user behavior analytics in the cyber security of the organizations. Let's talk about some stealth attack. During our research, my research, and seeing some incidents, I grabbed some scenarios according to the kill chains, and see how the attacker come from the outside to the organization doing some stuff and win all the security solution. We'll work on some examples, and then we will see how we can work with them. So before we get into it, some characteristics for a stealth operation. Stealth attackers investing a lot of effort in reconnaissance. They don't want us to know who they are. They want to hit us and to succeed. So like I did when I was in a red team, we build a lot of labs. We identify which type of solutions the customers have or the victims have, and then I try to build a lab and scenario in order to bypass those solutions. From the point that I was calling to the secretary from, hello, this is the IT guy, you have some problems with the computer, which type of icons you have in the right below screens? I have a red icon with the shield on it. Say, oh, okay, nice, can you click on it? What's the number? Okay, I will get back to you. And then it's so simple to do such a reconnaissance. And it's very critical for those type of actors that are trying to do stealth operations. Once stealth operation was only state actor were able to be launched only by state actors. It was so complicated, but today we have so many open tools that can provide those kind of abilities. Usually exploiting the human factor. Phishing is, I think, the best way to enter organization. And many of, like myself, thinking this way. They need to be evasive. As I mentioned before, slow and low. Slow and low is on the rise. Many attacks on small companies, not so big companies, many attacks on small companies use the slow and low to exfiltrate data or to scan the network in order to move laterally. Anti-detection techniques is like very common things. Now with the abusement of PSX, PowerShell, we can use the tools that the environments provide us in order to try to identify some things within the network. Move laterally all the time. The attackers wants to move laterally, wants to locate more resources and to place their footholds in more resources. And I think the bottom line is exfiltration of data or actual to cause a damage. Critical infrastructure is I think the best example of causing damage. Data exfiltration, I already show you the third slide about all the data exfiltration incidents that were in 2017. So let's start. I will give you like a basic flow and we can work on that flow later on. Spear phishing email. The attacker tried a couple of things. First of all, he sent an Microsoft Office a file through an email. When you open the file, it's communicated through SMB, sending the user hash credentials through to the remote server. Okay, it's very common and see a lot of phishing email with this kind of attachment. You can take the hash credential and to crack them offline and then to use them in order to access the organization. They also send 2 PDF files. The 2 PDF files, what with no code execution within. If you will send it to a sandbox solution, it will find nothing, okay? Because it's a normal PDF. The PDF contains some links. One link is to download executable, which also try to perform a CV of Microsoft Office for remote code execution. The other one just send you to a fake VPN login page. The fake VPN login page will learn users just to enter their VPN credentials in order to access the organization. This one is my favorite attack method. It works all the time, just to scan network, to check for open VPN interfaces. Just copy the page, open a domain that looks like the domain of the VPN, send it to the companies from some reconnaissance and some emails that we collected, and here you go. You have, after 30 minutes, something like 20 user credentials. Moving forward, all the users that actually fell down to those kind of tricks, installation, it's more for local persistency. Try to detect virtual machine, create local administrator account as a backup users, turn off the firewall, the Windows firewall, and open RDP access in case the computer is closed by RDP. So this is a way of installation and persistency because it wants to lateral move within the organization. Afterwards, the code from the start will not contain all the attack because they want to be stealth. They don't want to show all the cards from the beginning. So let's download the dropper, okay? The dropper will download the text file. The text file will be changed to an extension of executable from the last code that the actual victim downloaded, and you will try to download several files like this, and the files will use as attack tools in order to continue and attack the organization. After the dropper is there and the computer maintain a persistency and it try to evade and open the firewall and everything is good, let's connect to the command and control server and send some information. Usually when I'm seeing a command and control, they usually use HTTP and DNS. HTTP and DNS are protocol that are actually mostly open from firewalls, and most of the computers within the organization have open ports for HTTP and DNS. So the computer which actually infected and downloaded the installation and the malicious files will be communicated with the post request with encrypted content within the post request outside in slow and low procedures. Not all the time, but every couple of hours. Sometimes we see in a communication every day, like a beacon request every day, only one. For those that didn't were able to download all the files, DNS is more usable and more common to be open than HTTP. The DNS were open. They're using a DGA. From one of you who does not know, it's a domain generating algorithm in order to cover some tracks of the attack remote server. It's just sending a lot of DNS query with algorithm that changing the FQDN all the time. When he found the actual server is using DNS tunneling to exfiltrate the information for the non-compromised machines. Lateral movement, okay, we downloaded everything, we communicated with the server, we maintained the persistency. Let's move laterally, okay? Shared folder, let's search for shared folders, let's put inside the search folder and file. Let's keep it this way and try to lateral move with shared folder. Also, let's find a service. The two last steps is very common. Find a service account and to do some encryption downgrade, and maybe here you don't need encryption downgrade because the service account has SPN which already RC4 running on it, so you can crack it also in the remote server. Service account password is usually easy to guess. Service account usually running in more machines, so it will be normal to see that service account laterally move from machine to machine, so we want to compromise more service accounts. So it's a very common lateral movement phase. Afterwards, internal reconnaissance using PSX, we want to collect all the data we have from the endpoint. This one is just the NTDS file and system registry hive, and collect more host information into files. After collecting all that information, of course, I want to exfiltrate it outside. Again, looking on HTTP and DNS, sometimes you can also see a use of Exchange and email services that can take the information and send it as a regular email outside, which is also common. But in this case, they upload all the file with valid hosting domain, just because once you uploaded a lot of information, maybe the organization will look at it and try to use reputation services. If you use a regular domain with hosting capability, the reputation services will not catch it. And it may look like very authentic uploads. Also to smaller files, they will use again the DNS tunneling technique, which we will talk about it later on. So basically, the attacker infiltrates the organization, maintain persistency, and were able to exfiltrate all the data outside. This is just a cool picture that Symantec created. I really like it, and it's actually simulate and demonstrate all the attack scenario that we saw now. So the last phase, of course, is the data exfiltration. The cool thing about it that we have so many tools, so many open source tools that everybody can use, and everybody can use those abilities. Those tools also have some stealth flags that can help you do some slow and low activity, try to send some beacon outside, and you can also wrap those tools and those DLL and to try to modify it. It's super easy, so EDR and antivirus will not catch it. It's super easy today, and we're seeing a lot of attacks that using Cobalt Strike, let's say. A lot of Cobalt Strike models and Mimikatz models will be used in very high profile stealth operations. So it's very accessible today to everybody. The main reason, it's like, I just want to put that GIF because I think it's super funny. The perimeter security failed in this operation because it's very uncommon to attacks to obtain and to do some kind of activity. Great. So let's talk little bit about the blue team. Till now we covered really fast my perspective on UBA machine learning, and we work really fast on a common attack pattern, which should be a stealth attack. The attack pattern that I showed you, many customers with a lot of security solution didn't identify till I think minimum half a year after the data exfiltration was exfiltrated. So, blue team perspective. Now, are we going to look on those type of scenarios? So, this is the kind of data that I want to look for in order to learn the organization. Of course, you have much more, but the ability to analyze more data is limited. So I want to particularly look on particular sets of data which can bring me the most security value from that data. We're talking about Active Directory, Exchange, we have authentication, privileges, group, permission in Exchange, file access, file activity, which is very rare in a lot of security solutions to collect all file activity because it's very heavy. You have millions of file activity. VPN traffic, it's amazing. You can learn a lot of the organization from VPN traffic. A proxy server, all the communication inside, outside will cover your perimeter. HTTP, HTTPS is very common protocol. You can learn a lot of things about the organization using proxy. Firewall, of course, for internal movement within the organization, and DNS have a lot of value because many attackers use DNS as it's a kind of unrestricted protocol which you can play with and do whatever you want with. So we're going to look on query type, reputation for DNS, size, the same thing for proxy. So those are the actual places that we want to look for. Okay, so in those places, we have a lot of data. I can tell you that in organization with 100 users, 1,000 users, sorry, 1,000 users, you will have approximately 3.5 million events of proxy a day. It depends on the proxy vendor and the auditing that you're operating on that proxy, but it's crazy. It's a lot of data. And if we want to work with that data, if we want to run machine learning algorithm and UBA algorithm on that data, I really want to see that I'm working on the right data. So first of all, I need to discard irrelevant data. In the logs, we have a lot of trash, a lot of automatic logging of automatic services, of the services of the vendor, certificate-wise connection, all kind of things that I don't want to look on. And that reduction is very crucial because we want to save space, we want to save time, and we want to save some CPU usage. Normalizing the log format and grouping, and all the logs looks totally different from one vendor to other vendor is completely different. So if I now working with one proxy vendor and then moving forward to other proxy vendor, the logs and the activity will look totally different. In VPN, I saw that something like 15 lines, 15 row lines only for VPN authentication. Only for user authentication using VPN, you have 15 log lines. It's a lot, and if you're now replacing the vendor, you need to understand it also. So first of all, you need to understand the data, you need to remove all the logs that you don't need, and you also will want to group those activity to an actual activity that you want to search for. Enrichment, we will talk about it in the next slide, which type of data we want to enrich our logs, and drastically reducing the quantity, like I mentioned. So this is the type of enrichment that I'm aiming to work with before I'm implementing the machine learning and the UBA. So most of the data here also based on machine learning. If I will take the logs, I will need to give some indicators in order to learn what I need to learn. The first thing that I want to learn is user activity. User activity usually, it's like a normal user activity is the user have working hours, the user have personal computer, most of the user, maybe several personal computers. So I want to learn those kind of things. User peers. I want to learn which peers each user have in order to find the abnormality. And I will talk about it later on with the models. I want to resolve IP to hostname, IP to location. I want to take the seed IDs from the authentication and other events and find the seed ID and which is the username. I want to see the username. I don't want to see the seed ID. I want to be able to look for user account, service account, and computer accounts. Administrative accounts are super important to investigation. So I will need to search for them as well. Let's talk about superpowers. Now it's the interesting part. After going over the data, after going over the attack patterns, I will show you some example that I'm using in order to take that data to implement a UBA models on that data and to see how I can reveal some unmask operation. So the first of all is VPN. I already mentioned that VPN is super critical within the organization. It's all emphasizing the action from the outside to the inside of the organization. Everything from the outside needs to go through the VPN. Not everything, but most things. And I want to believe that mostly everything. So if I want to look on VPN, what's important for me in VPN is I'm looking on authentication and activity of users. So I want to look for peers. I want to look for the computer that the VPN connection connected to. I want to look on working hours, because if someone is communicated into the organization and trying to access the VPN not in his own working hours together with more stuff, it's a very strong indicator. I want to look on geolocation because I'm never logged in from Uganda, never. And if I will do that, I will want to see that, okay, Snir never worked from Uganda, but rest of the organization worked from Uganda. So I want to raise an alert only and to find and to investigate only Snir's activity because it's not typical for Snir to work from Uganda. Also, I want to see that if the user that provided the credentials and connected to the VPN is the actual user that did it. So in this image, you can see a raw log of VPN. We can see that it's connected through VPN tunneling. VPN tunneling specific to this vendor is the actual client of the VPN. And we can see that it's connected with a certificate within his computer. And also this certificate and the username are both for the same user. And it's also that user connected with his own computer. So from that log, I can take those kind of log. This is normal activity, okay? So I can take this normal activity and to learn it for the username Bob. So usually Bob connected to VPN through his computer with the actual agent of the VPN. The location of his IP is its own state. It's the US, okay? Bob is constantly connecting from the US. Bob is also a developer. Bob is not a salesperson. If Bob was a salesperson and he was in charge of EMEA, so I will know that Bob is usually connected from Europe or from his current office. I can use that IP enrichment in order to learn the activity of Bob, and then I can find some strange activity there. This VPN log will say differently The user Snir connected with RDP connection using a web interface. You can see the port. It's RDP connection using the VPN, but he connected to Bob machine. You can see that Bob machine is not Snir machine, but if I'm thinking about it, Bob machine also have some labs on it, and Bob machine, that machine specifically, maybe it's not Bob personal computer, maybe it's a lab. Maybe it's this one is a laptop, but it could be a machine which is not Snir's personal computer, but a machine with a lab, a machine that he used to connect to. So this is the type of activity that I want to resolve. Another thing is Snir usually working with a certificate and VPN tunneling in order to access the organization. This is the first time that this user is using RDP connection over VPN. So it's very abnormal, and it's using it to a different computer. So if I can learn the activity of the user and see where the user is coming from and what he's doing, I can raise an alert. Moving forward, domain controller. Again, service account, VS computer accounts, and user accounts. You can locate service account in your organization according to the service naming convention or SPNs or other properties that you have in the domain controller. Again, also for user account and computer accounts. Is the machine that you have in the organization, you can identify which machine are public machine, which are public servers, which are terminal servers. I want to identify those servers in order to reduce false alarms. And I want to check which of the machine are personal computer. What is the authentication amount of each machine? The authentication amount and places for each user. If the user is usually, or the service is usually authenticated using NTLM or Kerberos, if I have the TGT and the TGS for the same machine, so I can know that nothing's happened there. The encryption type of the ticket is also important. We will talk about it later on. So let's talk about abnormality, and in this case, lateral movement. So Joe is connected to many computers in this scenario. We can see that Joe is requesting a lot of TGT requests, doing a lot of TGT to different type of computers. Does maybe it's abnormal. Most of the users will see it's abnormal because why Joe needs to connect to many computers. But if Joe usually connect to those computers, because I have the history a statistic of Joe, so I can say, okay, Joe is just accessing those computers and it's okay. But if it's not Joe, it's a service account. And so combining those things together can help us to identify such abnormality. A typical encryption type. We have many attacks for encryption type of ticketing. We have encryption downgrade, Kerberosting. Most of the things that now security analysts identify is attacks, okay? This is how encryption downgrade is usable. Okay, someone downgraded from AES into RC4. Okay, it's a problem, but if the service already working with RC4, if it's usual to the organization, for some part of the organization, to work on this kind of encryption, why I need to investigate it, why it's a security issue. So in order to identify the real stuff, the real stealth and right attacks, I want to learn which type of encryption we are using within the organization in each segment, in each computer, in each user, okay? If I will learn it, I will know where to look for. And sometimes maybe it will use a RC4 encryption, but now it will use a stronger encryption. So this is abnormality. Eliminating the false positive here. one account access request to many PCs. Again, in this type, we have terminal server, we have QoS server, we have the best environment that the user is usually access to. So it's normal. We will never know that unless we have a capability to learn the events and to store statistics about those events ahead. So if we will be able to know which type of machines that user connected to, we will be able to know for any type of lateral movement attack. If I know that I'm usually connected to those computers and someone will control my computer and do something with it, he cannot know that someone is looking for a new computer, a new request, a new TGT request. Maybe if it's a backup process, and the backup process, first time, let's say, working on a personal PC of someone which never run this backup process, it's a problem. So this is why we need identification of user. So we already talked about personal PC, service account, previously asked ticket for those devices. We can use those type of event logs. I don't want to enter and to talk about pass the ticket because it's already talked about, everybody know pass the ticket. So if you don't have the TGT and you have the TGS, it's a problem, right? But what about delegation? You have services within the organization that doing delegation. If you have some problem with resolving the host name, so how do you deal with it? If you learn which type of services and computers implementing a delegation process, so you can tell that this is not pass the ticket because that service, I know, you have the probability of delegating those tickets. Proxy. So external access control can be VPN and also proxy. We talk about in the stealth operation that you can use proxy to lateral move and also to infect users. The service account actually usually going through the internet, rarely see that, okay? And if they're accessing the internet, maybe they're accessing the well-common trusted domain. Maybe it's the Azure or the Amazon account of the organization. If it's service account that using for development teams that actually upload code outside, it's a lot of code going outside, but I know that service account is usually access those domains. Do you access google.com by typing its IP? I don't think so. Usually when I'm seeing an addresses or directly accessed IP, I want to investigate it, okay? And this is one of the parts of the correlation that I want to perform. A typical data upload. I think this picture refers right. Because if I will ask you, how can you identify in your organization a typical upload, you will say, okay, usually a user upload till, I don't know, 5 megabytes per day in one request. One request with 5 megabytes will be very big request. I will know that it will be totally file upload. So I can count them, and if it will be like very massive, I can identify someone is uploading data. But for slow and low, it's not working. Okay, slow and low, you will miss it. And the other part is that if it's a massive upload, but it's okay because that user is usually uploading a massive amount of data. I can learn that from looking on the proxy log and combining the proxy log in the Active Directory log into the user machine and the user identity. So if I have the usual amount of data uploaded by that user from that machine, I can correlate those insights in order to create a model of abnormality. Again, the accountant is a real threat because the accountant is usually not uploading any data, and now he's uploaded very few files, but he usually not uploading any files, but this day he uploaded something like 20 files. So this one is very suspicious, and if he uploaded it from different computer, and if he access different computer and open a lot of files from the file events, I can correlate the data and say, okay, I learned that the maximum amount for that user is 2 megabytes per day. But today is uploaded like 5 megabytes and open a lot of files because I saw a lot of file activity. If I have that statistics, I can provide a good material for investigation. If we're talking about data exfiltration, it's very hard to obtain those kind of things. Threat intel will not help you to find data exfiltration to reasonable resources, reasonable domains, if it's hosting domains. So we need to build some kind of trusted domain within the organization. If you're looking on some statistic that I ran, 56,000 unique URL per user, per organization, 70,000 unique domain per the organization, and we can find with statistics some trusted domain. Trusted domain can be for many reasons of machine learning. Let's say this domain is used, the usage of the domain is used by a lot of users, and the same user is actually communicated with the domain. Okay, so we can see request response. So this is, from my perspective, is stronger than threat intel because I can learn the actual domains that are working with the organization. If one domain is a very good reputation for hosting servers, but nobody from the organization working with that cloud or hosting server, and now I see that someone is continuously working with that domain, I want to see what's going on there. So I need to find a way using the proxy logs and look in all the organization to learn the patterns, the trusted domain of the organization. If I will do that, I will create a better reputation by my own. Using machine learning, of course, we can learn it by the profile. User agents are very, very good indicator in this place. So the funny part is when I'm looking on my data and look for a pattern from user agent, I saw that you have thousands of user agents in the organization. Thousands. Many applications sending statistics across the line. You have like strange user agents which you don't familiar. You have user agent that specify a script activity, CURL activity. So you will never can identify only by this one, by the user agent, some abnormality because you have so many. So how you deal with it? Using the machine learning, if you look for past data, you can look for user agents that are used by your organization. The same as we did for the URLs, for the domain, trusted domain, we can build a image, a profile of trusted user agent. So in this case, you have the CURL and Python. Those two user agents were used by the DevOps users. So from other reasons, you will see that as, okay, this user agent is very unique. I don't want to investigate it. But I know that my users are usually using that user agent. I learned it, and I use the machine learning to learn it and to calculate statistic how many and which profile are using that user agent. You can see the third one, it's Mozilla Firefox, right? The Mozilla is using the user agents written Linux, but I don't have Linux computer in my organization. I have only Windows. So this may indicate a breach. This may indicate a data exfiltration. The one below, it's pretty interesting. Can you see the account name, which is the administrative AV? It seems like, I don't know if you're familiar with some antivirus sending a lot of HTTP requests with some things that looks like data in base 64 wise within the user agent. So after running some calculation and some calculation and machine learning, I was able to find some domains that constantly change the user agent in each and every request. So this may be very, very triggering, because why something will do that and it's not in my trusted list? I didn't learn that user agent. The user agent is continuously changing. So the fact is, some of the security solution using those kind of headers in order to send statistics, and if you have that vendor, you cannot do anything, and it's okay. So you don't want to investigate it every time. While working with machine learning, you can identify those kind of patterns, and to identify that pattern from user agent is very legitimate to the organization, because all the organization users are sending those kind of requests every day. Every day you have a bunch of those kind of requests, not for specific users, for all the users in the organization. You may need to investigate it because it looks very interesting, but it's not abnormal. So it's actually not abnormal, it's just a way that the security solution works. Going forward to learning DNS traffic. DNS is very straightforward. And because it's very straightforward, you can have a lot of false positive if you're not learning from past activity. First thing and the simplest thing is zone transfer request. So zone transfer request usually performed by DNS servers, dedicated server to sync. So why someone who is not a DNS server or not an actual IT server will send this kind of request? It's strange, and it's more kind of a pattern. So in this case, you say that you don't need an actual behavior analysis to analyze those kind of things. But if you're moving forward and looking on PTR and reverse lookup is when you send a DNS query with host with IP. You already have the IP and you want to get the host name. Attackers usually use the DNS server in order to reconnaissance the organization, sending some reverse lookup request in order to get all the server name and to identify the right servers that they want to target. So it's very easy. Let's find a machine that sends in a lot of PTR, a lot of reverse lookup requests. We will identify them, and then we can say, okay, it's a risk. Some example of why it's not going to work without machine learning. You have in the organization some IT tools that using the DNS to resolve IP to host names or host name to IPs. One example, SolarWinds is doing it. So if you have some servers with some solution within the network, you will see that they constantly changing, sending a reverse lookup request of DNS. You will alert and you will investigate each of them. You will get 100. You have no power and you cannot provide the right information about these kind of attempts. So if you learn the DNS activity of your organization per each machine, you can see that, okay, this one is very noisy, but you cannot discard him. You can build a learning model for this one also. So it will be very powerful, and you can learn that, okay, this one is usually trying to do some request for reverse lookup. DNS tunnel. Count failed of requests. So let's say that, let's talk about DNS tunneling in 1 second. DNS tunneling, and when you exfiltrate data by putting the data we want to exfiltrate in the subdomain, and you constantly change it per each request, and you send it to the remote server. So I can say the simplest thing, let's listen to failed DNS request, because it's the simplest one. The problem is you have plenty of them. Plenty. You have so many failed DNS requests that sending across the net, which is crazy. So let's find a DNS request that have upstream, that actually going outside and not staying inside the organization. But it's also a problem because sometimes it's have upstream, but it's for like configuration error or some, I don't know, some server that you mistype it, or the IT guy runs some script and mistype the server, and all the data sent outside. So you cannot learn, you cannot know what's going on if you not learn those kind of things. Application, as I said, is using also the DNS for resolving, and if they try to resolve some servers in some places which are not exist anymore within the network, it will cause a lot of noise in your identification. So from my perspective, if you will learn for a profile or for a machine, not for a user, the usage of DNS, you can identify those kind of stuff. To close all the conclusions, so UBA is great. We know that, we saw that if you will learn the profile, if you will learn the machine, you can identify much more than you can do without learning the actual scenario. So what's next? We talk about the specific places in the organization, and now we can learn from them and to find abnormality. So I think the next one will be is correlation. Let's correlate between DNS and proxy. Let's correlate between proxy and exchange. Let's correlate between different type of places using machine learning and UBA in order to find one abnormality and the different abnormality in order to create a full picture of attack, which will finally may help us to identify those kind of stealth operation that we cannot identify using a dedicated pattern because of how the organization is working, and that things within the network are constantly changed, and we need to learn what is changing and what is stable. By creating those profiles, we can answer those kind of attacks. Thank you very much for your time. Questions?
Thank you. How do you manage the learning curve when your network is already compromised?
Sorry, can you repeat?
If the network is already compromised during the learning phase, how will you manage that?
The problem, it's one of the biggest problems with UBA. The problem is if you learn in your learning period the attack, you will learn the attack, but if you already learn the let's say peacetime activity, and now the attack is happening after learning, you can learn for 1 week, 2 weeks is enough in order to identify most of attacks. But if in the same time you are learning the activity, the attack is happening, you may miss it. But you can use peers, because if the attack is happening in one user and not on the other user peers, let's say I am an engineer and I have a group of 5 engineers, if the malware or the attacker didn't attack all the peers, so this one is abnormal to his peers. So maybe you can identify it if you will correlate it correctly. That's a good question.
Thanks for the talk. I'm wondering, how do you cope with all the different technologies? Because you've mentioned that, but I don't remember you explaining, let's say, how you manage, I know, different types of proxy devices. Do you somehow process this data manually or map it manually, or I know, is it provided by vendor?
Yeah, this is also a good question. As I mentioned before, the pre-process of completing the machine learning process is to take the data and to build an activity from that data. I think you must do it manually per each vendor. More questions? Okay.
Okay.
Thank you very much, guys.
Thank you.
Enjoy your evening.